This is question 3 from the higher level paper 1 from the 2020 Leaving Cert exams. Up the top right of the screen, you'll find a card that will bring you to the playlist that has all my solutions to the questions in this paper. And in the description below, you'll find a link to an image of this question so you can try it before looking at my solution. In part A of this question, it gives us these two functions, fx and gx, and it asks us to investigate f of gx, whether it's equal to, I'm going to spread this out for reasons you'll see in a moment, whether it's equal to g of fx. So to do this, let's simply find out what this is. Let's find out what this is and see if they're equal to each other. So to do that, we just need to do a function twice. What I mean by that, this is saying f of something. In this case, the something is gx. We already know what f of something is. F of something is equal to 6 times that something minus 5. In this case, the something is gx. So I could put gx here, or instead of gx, I could actually put x plus 5 over 6. That's how we do a composite function. We write the first function and the second function everywhere there's an x for that one. We multiply this out, let's see, 6 and the 6 will cancel. So we're just left with x plus 5 minus 5. So that's actually just equal to x. Similarly with this one, we're going to take gx, g of something is equal to something plus 5 divided by 6. In this case, the something is fx, and fx is just 6x minus 5. Let's see. Minus 5 plus 5, the bracket doesn't care about, actually the bracket here is not going to do anything. So minus 5 plus 5 is 0. So we're left with 6x divided by 6, which is just x, which is the same as this. Now something else interesting. Oh, well, let's finish answering the question. They've asked to investigate if this is equal to this. Write a conclusion, therefore, something along the lines of, therefore, well actually I'd write this, therefore f gx is equal to g fx. And that's all. That's all you need to write. One thing I'd like to point out though is, if a composite of two functions is equal to x, that means they're the inverse of each other. So they're actually the inverse of each other. If you want to do the opposite function to f, gx is that. If you want to do the opposite of gx, fx is that. Now, it's not part of the question, it's just something interesting to note. I'll rub this out and we'll do part B. In part B, they give us this function here, y is equal to 5x squared. And they ask us to show that it can be rewrote in this form here, where we don't know what a and b is. So to do that, y is over here, and also log to the base 5y is over here. So that should be quite easy to get. We just take log to the base 5 of y. Now if you're going to do something to one side of a function, I think we all know by now that if you're going to do something to one side, we better do it to the other side. So log to the base 5 of the other side, 5x squared. That's fair enough to do. That's fair game. We did it to the left, we did it to the right. And now, really, what the goal is to get it to look a little like this one. So that's where we're going to start. We're going to play around with this, and hopefully it will look like this in a few moments. That's the hope. If it doesn't work, we start again with another idea. Thankfully, it will work in this case. Okay, so one of our rules about logs is log to the base anything really. A log of a function that has two things multiplying. There's two parts of this multiplying each other. You can rewrite like this: log to base 5 log to the base 5 of 5 plus log to the base 5 of x squared. We can separate it out like this. This is just numbers. We can put this to a calculator, or we might know already ourselves. Log to the base 5 is asking us a question. What to the power of 5 is equal to 5? And the answer is 1. Or if you're not good at doing those things, put it into a calculator. There's another rule about logs is log of something with a power. That power can come out front. So 2 log to the base 5. And we're already there. We've got it looking like they wanted it to look like. So we have log to the base 5 of y is equal to a number. a number, in this case it's 1. Do they tell us these are integers or anything? No, they just say a and b. So indeed we got a number here, 1 in this case, plus a number multiplied by log to the base 5x. In this case it's 2. So really we just tell them that a is 1 and b is 2. I think they ask at the bottom of the question in the actual exam to write in a and b. Whereas I think this would be full marks anyway. Now for part 2 of this question, they give us a function that looks a little like this one here. Let me write it out here. Log to the base 5y, same as this, is equal to 2, okay, different number, plus 1, different number. Worryingly enough, they're the opposite of each other. So I'm guessing some students might have thought, oh, maybe I was wrong here, which is unfortunate. Sorry, they don't write 1, obviously, because 1 times log is just, you wouldn't bother to write it. And then a function here, 126x divided by 25 minus 1. I'm just going to leave it blank like this because I think it will help us think this question through. Because we don't need, all I need here is something. That's a something. At least that's for what I'm going to try to explain. Because all of this function here started with y is equal to 5 something squared, and that could be made to look like this. In fact, I'm just going to write y is equal to 5x squared just here, so we have a clear lineage of what's happening here. Because I'm going to work backwards here. Now, sorry, you could do this question slightly different. We know log to the base 5y is equal to this, so I could just put this part here and equal it out. There's only x's then. It will take a few minutes, but it could work. But no, I'm going to use the idea that this is related to this. And let's see how. Where did this 1 come from? This 1 came from the fact that there was a 5 here. This 5 came from the fact that there was a 5 here and the 5 was here. So the 1 is directly related to this 5. This 2, well, let me say again as well, the log to the base 5y is directly related to this y. So that's a bit clearer. Y. This 1 is directly related to this 5. What would this 2 be related to? It would actually be related to a 25. Because the 2, if there was a 2 here, there is a 2 here, log to the base 5 of what is 2? So it must be a 25 there. Means there must be a 25 up here in this question at least. And this 1 is related to the power. Or before that, what's inside the bracket at the end here, it's related to what's here. So it's 25 something to the power of 1. This 1 gives us this number. This 2 gives us this number. It's 5 to the power of something. I could write it like that if you'd rather. 5 to the power of 2. That's where that 2 influences this question. And what's here is simply what they gave us. 126 over 25x minus 1. 126 over 25x minus 1. So I could, instead of equating them earlier, I could use the same logic I got this question in to get to this part. So that would be a choice to do it. I may have gone over people's head there, so I apologize if I did. At the end, I'll quickly sketch out how you could do it a different way. But this is how I would have done it. I would have got y is equal to this. But I also knew y is equal to this. So I can equate them together. Y is equal to 5x squared. Y is also equal to 25 multiplied by this. Oh, I'm sorry, I'm missing a squared there. Y is equal to this. So these are equal to each other. So the top row, 25 times, let me write this one out again. 25 multiplied by this, the 25's cancel, and 25 times this. So I get 126x, that's here, minus 25, that's 25 times that, is equal to 5x squared. So now I just have to solve this quadratic. Let me rub this out here and make some room. So we've got this quadratic. Let's rewrite it as well. We have 5x squared and minus 126x. I'll imagine everything's over the same side. Plus 25 is equal to 0. Can we solve this? Divide everything by 5 would be nice, but no, I can't do that. Let's try and factorize it, but we can always use the minus b formula if needed. Two things to multiply this. This is easy because it's a prime number. It has to be 5x and x. Now, loads of choices here. We need a nice big number to get to 126. So 25 would seem to be a possibility. 25 times 1 would get here. 25 times 5 is 125. Plus another 1 is 126. So that would seem to work. They both have to be minus to get to minus 126. Two minuses would make a plus for this. Okay, so this looks like we're right here. X is equal to 1 over 5 and x is equal to 25. They didn't ask for x though, they asked for y. Y is equal, we could use, let's just use this one because it's the one. I haven't cleaned this one up yet. So if I put in 1/5 here, well, let me write them out. Y is equal to 5 times 1/5 squared, which is equal to 5 multiplied by 1 over 25, which is 5 over 25, which is 1 over 5. And this one here would be, this is going to be a big one, y is equal to 5 times 25 squared, which is equal, I'll have to check my notes on this one, is equal to 3,125. So there are your two answers. Y is equal to 1/5 and y is equal to 3,125. Oh yeah, I promised to quickly sketch out how you could have done this otherwise. At the start of the question, you could have said, you have this line here actually. You could have rewrote this line because you knew the answer, you knew what this looked like already. This would have looked like, let's see, 1 plus 2 log to the base 5x and is equal to this side. So now what you can do, let me rub this out. We'll pretend these are all the same line. Now you can start rearranging this. All the logs to the same side. Get them all to log 5. So maybe bring this 2 back inside. Two logs can add together, or they'd be taking away from each other. So then you'd just get something in the inside. Let's say I got everything this side. I get something like x divided by 126 over 25x minus 1 would be all the logs that side, is equal to, this would be all log to the base 5 here, which is equal to, I guess, 1 on this side. So you could just take both sides, put both sides to the power of 5. That would destroy this log. 5 to the power 1 is just 5 over this side. And you should continue this on. You get the same numbers as you would get here for x's, put them in, get the same numbers for y's. I rather my way, I think. It's just a bit more elegant, but I understand some students might not have followed. So I'm a bit worried I probably should do it all again in this way. But ask in the comments if you are really desperate for that and I'll redo the video in that sense. Thanks for watching. Have a great day.